So it's Immutable.js, the last talk for today. My name is David, and tell me on Twitter how you liked it. I'm the Tanzer there. So the motto for today is Angular, right? So I wrote an Angular app. No, just kidding. This is React, of course. No, not that I don't like Angular. It's great. I've been working with it for 9 or 10 months now, but I think this one drives home better the point I want to make, and also I didn't want to rewrite all the examples I already had. So yeah, I wrote a React app, and oh, by the way, if you correct me when I say something factually wrong, you'll get a React book, or a book about agile anti-patterns, whatever you prefer. This one has more JavaScript, but this one has nicer pictures. So, anyway, I wrote the React app, and who here knows exactly how React and Redux work? So yeah, that's not everyone, so I guess I should explain it, right? So, this is React. This is from my React training. Normally I would draw this live on stage, but not much time left. So okay, React allows you to write components or write reusable components, write tags, something that looks like HTML tags in JavaScript. It's a library, no batteries included. You have to do a lot of yourself or use different libraries to do it. But basically, React allows you to write components. A component has a render function. It has props, which are values that the component gets from the outside, maybe from its parent component. And it has a state, which are basically values that the component can manage itself. So, and whenever the props or the state changes, React will automatically call render, and render returns something that looks like HTML or looks like the DOM, but now this is important, it isn't HTML or it isn't the DOM. So, whatever the result of render of all the components is, goes into React, where React will compile a virtual DOM from it, and then diffs this virtual DOM to the previous virtual DOM and creates something like it. These are technical details, and they are important because the browsers are stupid and slow. So, but then in the end, the browser will render something, and you'll see something on the screen. And all of that happens completely automatically, so some value in the props or in the state changes, and the user will see something on their screen. Now, the way back is not automatic, so when there is an event in the browser, a DOM event, or when there is some external event, some asynchronous backend call returned, then we have to write code. And usually in React, we call set state on one or more components, and they will re-render, and the user will see the changed state. So this is nice. It works very well for small applications. It's really fast because React tries to optimize aggressively at many different points in this flow. So it's normally fast out of the box. Don't worry, you can still write slow applications with React, but it's a little bit more difficult than with other technologies. Anyway, so, but it doesn't scale very well. I mean, it stays fast even if you write big applications, but it doesn't scale very well from a developer sanity point of view. So the bigger the application gets, the more complicated this becomes, and suddenly you're in callback hell and delete all your code and throw your laptop out of the window and wonder why you didn't learn a real job. So Facebook came up with the Flux architecture, which is basically state management for React apps, and it's nice and does everything, but it's a little bit complicated. So then Dan Abramov wrote Redux, which is basically the Flux architecture, but usable. So with Redux, the picture looks like that. We still have React, we still have a render function, we still have props, but we don't have state anymore because we don't want the components to have internal state. Then everything from here to the browser is like before. The props change, the components will re-render, the users will see some changed graphics in the browser. But the difference is that with Redux, you try to put all of the state of your application into a single place. There's a single source of truth, and this is the Redux store, which is a very nice word for a big JavaScript object that contains everything. Yeah, so you put all your state into one big JavaScript object and put this into the Redux store. And to connect your components to this store, you will usually write some wrappers around these components. The container component that I drew in violet here. So you create those container components with a single function call that's called connect, and you implement a function map state to props that gets the state, so it gets the big JavaScript object, and it returns a smaller object with only the values that this one component needs. So now we have two components. The container component gets the state and it extracts what my component needs, and the component renders it. So we separate here the how is the data rendered from how do we get the data. And this is really nice for larger applications. Anyway, so we have data in the store, and whatever is in the store gets automatically rendered to the browser. So everything from here to the browser is still automatic. The way back is still not automatic, so there is a DOM event. And in this case, with Redux, we call a pure function, an action creator, which gets the event and creates an object that's called an action. So an object that describes what happened in this event. If you know domain-driven design, you would call this a domain event, but I guess they called it action so that you don't confuse it with DOM events. So, and you will use the previous state and this action to compute the next state. And this happens in a reducer. A reducer is a single function that takes the current state and whatever is in the action object and computes the next state from it. So basically this is the Redux flow. So something changes in the browser, there's a DOM event, we create an action object, put it into the reducer creates the new state. Map state to props is automatically called for all components. The components where something has changed render, React optimizes something, and the user sees a changed result. And this is really, really fast because Redux also optimizes aggressively, and it scales very well. This works well enough for small applications, and it still works very well for large applications with either a lot of different components or a huge number of components shown on the screen, which is not necessarily the same thing. So I was working on an application with tens of thousands of components shown on the screen at the same time, and I think this whole cycle took 100 milliseconds or so to re-render all the components. Or, I mean, they don't really re-render because everything is optimized. Okay, so I'm gonna show you some code in a minute. So I wrote this React app, and it renders an SVG, and it has some event listeners. So when I drag these squares, okay, there's a little bug. I think I should fix it. Yeah, in the next 20 minutes. Okay, but let's see how it's supposed to work. So these squares and the lines are React components, and they render SVG. And they get their data from Redux. So the initial state, or what's in the Redux store, looks like this. We have basically the data that's interesting for the components, the nodes with their x and y position, which are the squares, and the edges with an x and a y position, and the position of the square to connect to, and lots of other data to just show you how this would look like in an application that does not only have squares and lines. So there might be other data, and we don't want to lose this other data. Okay, and let's look at a link. So link is a React component and this is the inner one of the two components, the presentational component. It just gets data from the outside, it gets props, it gets the x and y position of the edge and the x and y position of the square, and it renders a path, it renders this one line. So it doesn't know how to get the data, but when it gets the data, it renders a line. And then we have the container component, the violet one from before. So this is just the result of a function call. I wrap the link into a component that can map the data from the state in the Redux store to the props of the component. So in this case, map state to props gets the state, and from the state it reads diagram.layout.nodes and then the node it got from the outside. By the way, if you do it like this with own props, that's slow again. You could make this faster, but it's different exercise. So we have some state in the Redux store. The nodes and edges. Map state to props maps a little part of this big object to the props of the link component, and the link component renders some SVG. And the square does all that too, but it also has action listeners, action creators. So there's an action creator square moved. So whenever you move the square, this function will be called, and this function just returns an object that has a type called square moved, and it contains the ID of the square and the amount of pixels the square was moved. So on mouse move, I just call this square moved, and the object that is the return value will automatically be dispatched to the Redux store, where it ends up in the reducer, and the reducer takes the current state and sets the x and y position of the square. And this doesn't work. Here is the bug. Anyone know what the bug is? Well, one of the three, yep. Yes, I mutate the state. I just change something in the state and then return the state. So one of the three principles of Redux is read-only state. So the result of the reducer cannot be the state that was in the store before. So let's try something. And so I created a new state object that just contains the old state. And this, yeah, almost works. So, good enough. Okay. So goodbye. No. Okay, I'm gonna show you the real implementation, and it's not something that I want to type here. So I could check out that's 2dbc. And I should probably first undo my changes. So now the application works. And basically, I still change the old state, but it doesn't matter because I'll throw it away in a minute. I still change, no, I don't. I create new nodes. I don't change the old state. I create new nodes and just set the one node that I want to change. And then I return an object that contains all of state and a diagram property that contains all of diagram and the layout property that contains all of layout and the new nodes. So it works, but oh my God, this is ugly. I mean, would you? No, this is. I mean, it would. It would be even uglier with old JavaScript and without the object spread operator, where you would do object.assign in every second line here. But this, no, we can do better. So let me cheat one more time. So I wrote two mostly empty classes that I want to show you now how to implement immutable data structures by hand, and at the end of the talk I want to show you how to do it with Immutable.js. So, but first, why would you want immutable data structures? So one obvious reason is that when you have read-only state, that theoretically no one can change the state while you're not looking. So like there's an asynchronous server call returning and it changes your state, and then you have to react on it. This is very, very complicated. When you have read-only state, this is much easier. But as long as we have normal JavaScript objects in here, nobody guarantees us that we really have read-only state. And this is not only true for Redux, it is often very useful to have immutable state transitions. So to not mutate an object, but to create a new object from an old one. And you really want a library for that. And the second reason is with read-only state transitions, especially here in Redux, all of this becomes a pure function. So we have the state in the store. We render something to the screen. This is a pure function. What's shown on the screen is only a result of what's in the store and the code in here. And then we have a DOM event as the second input, or an action. And with the state that's in the store and the action, we create a new state. So the whole picture is one huge pure function that's easy to test and easy to reason about. And every part of this picture is again a pure function, is only a composition of pure functions. And this is again very easy to test, very easy to reason about, and everything's decoupled. So you do not need dependency injection or something like that, at least not for this. Okay, and I have 10 minutes left. Okay, so what I really want here is to do something like, and I just switched to a Git version where I created my own from.js function, which takes this JavaScript object and creates some data structures from it that I wrote. It looks like this. I have a map that's basically just a wrapper for a backing object. And it also contains all the keys from the old object so that I can still use it read-only. And I have a list, which is just a wrapper for an array. And what I want to do here in my reducer is when the square has moved, I just want to return state dot update in. And I want to give this method just a path of the value to update. So I want to update the value in diagram, then the value in layout, then nodes, then action ID, and then X. Okay, but how could I update this? By passing in a function to do the update. So X becomes X plus action.dx. And I also want to update the UI. And here I need the square brackets. So y becomes y plus dy and y. And you said the first one was not ugly, but this is nicer. Yeah. I'll show you something without strings at the very end. And one thing here, if you use a static type checker, if you use a flow type, you can create types for these things with or without the strings, and you can make your type checker make sure that you don't access anything that doesn't exist. I think TypeScript can do that too, but maybe not inside the update in. Okay, how would we implement update in? So now it gets a little bit complicated. So a simple update of a single value would be, I'm in the map here, yeah. So I have to copy the old backing object. Then set the property. And return a new object with this new backing array. A new map object. Okay, and I want to update the whole path at once. So if the properties length is 1, I want to return update with props of 0. And otherwise, I must do this new backing stuff again. But in this case, I do not call the updater. I call update in again. So I know that because the path of the props is not a single value yet, I know that the user expects this to be another immutable object, whatever is inside of backing. So whatever is inside of backing at the current position, I want to call update in. And updater. And this doesn't work yet because I need the key and I need to remove something from the props. So I want to do something like const key equals props.shift. Yeah. And we basically need the same thing for the list with some minor changes. So in the real world, you would probably, no, in the real world, you would not implement this yourself. So okay, here we create an array as the new backing, and here too, and this should be it. So who expects this to work? Me not. Sorry, but no. Update is not defined. Yeah, of course update is not defined. Why didn't anyone tell me? Ah. I'm doing too much Java lately. Sorry. Prop is not defined because... Where? 25. Oh yeah, here we would have key again. And I also don't really do clean code lately, as you've seen. So, key. And here it should be named index, but don't care about that yet. And everything works. So now I have my immutable data structure. Whenever I want to change something, I create a completely new object, actually 2 new objects, the backing object and the map or the list. So this is really, really wasteful, but it works. I want to show you one more cheated code before I go to Immutable.js. So, and this is 2ADF. Which still works. But here I also have in the link, for example, you can also see I have implemented get in. So I can not only update something deep inside a path, inside an immutable object, I can also get something with a path. and I can call get on a single object. And now, because this implementation is wasteful and stupid, we use the real one. And everything still works, but it's probably orders of magnitude faster and uses orders of magnitude less memory. Because one of the things Immutable.js does is optimize the data structure. So when you create a new map where only a single value has changed, then it basically shares all the values that didn't change. So it's very memory efficient and also pretty fast. So I think when we benchmarked it for this application with the tens of thousands of components, it was somewhere around 30 to 50% slower than normal arrays, which is pretty good for it being immutable and not having some of the problems of real arrays. Okay, and I promised you to show you something without so many strings. So, no, I can't do this. I must undo my changes before. So far I've only used maps and lists, which are basically equivalent to arrays and objects from JavaScript, only immutable. And there's another nice feature, which is record, where I can define record types. So here I define a type node, which is a record, and a type edge, which is a record. And I say that the node has an x and a y position, and the edge has x, y, square x, and square y. And now these records allow me to access the values directly, and they make sure that I don't set any other values in there, or that I don't get any other values from in there. So they are basically constraining me to only use the values that I used in the record definition. And again, when you use a static type checker, I don't know if TypeScript can do this, but with there are flow types for these record types, so that you can really type check these record types. So I could create another record type for the whole state, and then I would not have so many strings anymore. So here I say that the edges are edge and the nodes are node. And in the link, I can again just access the properties. I can just say edge.x instead of edge.get the string x. So that was it. The conclusion of this talk is that in many cases, immutable data structures make your code easier to reason about and safer against unwanted mutations. And if you want to use immutable data structures, Immutable.js is one of the final libraries to do that in JavaScript. There are others. And especially when you want to use React with Redux, Immutable.js comes in very handy. You can statically type check everything in here if you use flow type and probably TypeScript. And yeah, that was my talk. So if you have any questions, I will have time for it in a minute. But I didn't really tell you who I am yet. I guess most people here know me, but I'm a freelancer, so I develop code for money, but I'm also a trainer and technically agile coach. So if you want to learn test-driven development or practice agile engineering practices with your team, or if you need help with your legacy code, then and I'm on the web, I'm on Twitter, I'm on GitHub, and I'm on YouTube, and you should follow me everywhere. And tell me how you liked this talk. Also, one more thing before I have time for questions. I also organized the Socrates conference here in Linz, which is the best JavaScript, maybe the second best. But it's the best DevOps, no, the second best in Linz. But it's, no, it's the best generalist software development conference in Austria, and I'm pretty sure about this. And you all should buy a ticket because they are really affordable. And we even created a discount code for this meetup. So The discount code is Stahlstadt, not the number 19, and you can get tickets at Socrates Conference AT.